Hi, my name is Lindsay Schmidt. I'm a consultant at Kapur and a member of our Smart Cities team. On behalf of our whole team, I want to welcome you to Kapur's Smart Cities webinar series. So what is a smart city? Some might define a smart city as an urban area that uses an electronic Internet of Things and sensors to collect data. Insights gained from that data are used to manage assets, resources, and services efficiently. In return, that data is used to improve the operations across a city. With this webinar series, we hope to help educate and inform local government staff and officials about the use of smart cities technologies. We want to begin a dialogue about this topic and answer questions like, what do we see happening today? What do these applications look like and how do they perform? And lastly, what does the future of a smart city look like? We also want to be a resource to help local leaders see where the opportunities are for you to apply smart cities technologies in your communities. Where is it cost effective and where may it be required for regulatory compliance in the future? If you work for a city, we know that you need to look to the future and plan for investments in your communities and educate yourselves on emerging technologies in order to become more efficient. We want to help introduce you to some new ideas, concepts, and technologies so that you can fully optimize your operations. If you're an elected official, we want to help you see the ways in which technology is developing and the value it can add to your community to both enhance the delivery of constituent services as well as help make those services more affordable. In an era of increasing pressure on local government finances, we understand efficiency is of the utmost importance. Smart cities require the marriage of data collection, sensors, and infrastructures. All type of local infrastructure, including drinking water, water reclamation, transportation, waste disposal, energy, and communications can be impacted and improved through the adoption of these technologies. Investments can be optimized for performance and financed through the effective use of smart cities technologies. Through this series, we hope to help you and your community find the best opportunities to integrate sensors with your infrastructure and to help develop as a smart city. Now I'd like to introduce another member of Kapur's Smart Cities team. Tom Fote has been with Kapur for 31 years and currently oversees our utilities section. He's played an integral role in fostering Kapur's Smart Cities team, assembling our group and supporting our mission to be at the forefront of marrying our communities with emerging technologies. I'm pleased to present Kapur Senior Associate Tom Fote to share a little bit more about our organization.
Good morning. My name is Tom Fote. I'm a senior manager at Kapur & Associates and a very proud member of our Smart Cities group. I'd like to welcome you to the webinar this morning and thank you for joining us in webinar number 2 of our Smart Cities webinar series. This webinar is entitled, Why Smart Cities Need Smart Buildings. A few years ago, we took a look at developing the Smart Cities group with a couple of goals in mind. One, to take a look at what makes a smart city. Is it technology? Is it a product? Is it a process? Is it all of the above? And goal number 2, make sure that we're presenting these technologies, products, processes to our staff as well as to our clients to make sure we're incorporating the latest and greatest into our solutions for our clients, as well as making sure those solutions meet our clients' long-term goals with the advance of these technologies. We know that within the different sectors we serve, a lot of this infrastructure is all interconnected. We know if we build a roadway, that roadway is connecting municipalities. That roadway is providing access to the private developments that we are helping to create. Those private developments need the public infrastructure connected to them. They need sewer and water. They also need the private utilities, another sector that we serve, for gas, electric, and telecommunications. We also know that those facilities sit within the roadway right-of-ways, so that physical interconnection we've been dealing with for a long time. What we're finding with the smart cities technologies is that they become even more interactive. We know that there's going to be sensors in roadways and buildings and parking lots that help monitor traffic flows and parking capacities. We know that there's going to be sensors in facilities owned by the utilities that may be assisting in traffic counts or video surveillance or video monitoring. So we want to make sure that we are understanding and incorporating these technologies, presenting this information to you as well as our staff so they're aware of the technologies that can best fit your needs long into the future. So we thank you for joining us. We look forward to presenting several more of these technologies in future webinars. And now I'm going to turn things over to Jeff Stone so that he can introduce today's speakers. Thank you.
Thank you for that introduction, Tom. It's my pleasure on behalf of the Smart Cities team here at Kapur to welcome you to our webinar series and to have the chance to introduce the speakers that you're going to be hearing from today. The first of those speakers is Jeff DeVor. He's one of two partners at Automated Energy Solutions, and he has a mechanical engineering degree from University of Wisconsin at Madison. Jeff is also an MBA graduate of Lake Forest Graduate School of Management. Jeff has over 25 years of experience working in some of the most innovative energy companies in the country, and he's going to bring that background to our discussion today. And he also has extensive experience in energy funding. Finally, he is an adjunct professor at the Marine Park Technical College here in the state. Jeff's partner is Joseph Schmidt, who's also along with us today, as well as being a partner in Automated Energy Solutions. Joseph has a bachelor's and a master's degree from Marquette University here in Milwaukee. He also has 10 years of experience as a general contractor and also working in energy improvement for buildings. He's a licensed engineer, and he's also a certified energy manager. We also have a special bonus to our program that we didn't get the chance to tell you about, but it's we're pleased and to have the opportunity to have Ty Miller with us. Ty is with Schneider Electric, and he has a unique background that he's going to bring to our discussion today. He has degrees in chemistry and also in political science, as well as an overlay of a master's degree in business administration from Notre Dame. So he's got a great background, combining both technology and public policy, as well as an understanding of business and finance that's so important when we're talking about how do we create smart buildings for smart cities. He's worked on federal programs. He understands kind of how that policy integrates with the reality out there in the world. In a program in Chicago, he worked with over 50 buildings, integrating them into a smart grid in the city. Finally, he has 19 years of experience with Schneider Electric, so he's been doing this for a while and is going to share some of that experience with us today. So as we go through the presentations and as you're listening, if there's questions you think of, please feel free to enter those in the chat box and share those with us. We're going to come back after the presentations. We're going to talk about your questions. We're going to talk a little bit more with all of our presenters together and take that opportunity to dive into the topics that you're interested in just a little bit deeper. At this time, it's my opportunity and pleasure to ask Jeff and Joe to help kick things off and take it away.
Thank you, Jeff. My name is Jeff DeVore. With me is Joe Schmidt, and we're from Automated Energy Solutions, AES. Primarily, we're a building automation company with offices in Green Bay and Pewaukee, specializing in systems integration and building automation systems. Today, we'd like to talk a little bit about what is a smart building, what makes a smart building, and how it plays into the overall concept of a smart city. It's a buzzword we hear quite often of what is a smart city. We think that the smart building is a large component of that, and we'd like to discuss how that interacts into the overall concept, and then at the end give you an idea of how the smart building interacts with the overall municipal and the other services provided.
Smart cities need smart buildings, in these to highlight these four key areas of why smart cities need smart buildings is not necessarily number one in order, right? But the way we have them shown here, reducing the operational expenses, improving your employees' wellness and safety, serving your constituents and those that use your buildings for business, and then ultimately monitoring the analytics, which will serve as the key gateway to connecting the smart building to a smart city. So one key thing to highlight though is that reducing your expenses and the outcome or the benefit of that is achieved because you have a smart building. It's a result of proper planning and proper execution of a smart building versus typically that being the primary driver.
Yeah, and Jill, the two middle items probably are more meaningful now than they've ever been.
Absolutely.
With serving the constituents and improving wellness and safety. And what we mean by this is there's a tremendous amount of data in these buildings, all collected in a building automation system, which most commercial buildings have of some type of vintage at this point. And why is that important to wellness and safety? Well, with current pandemic, we want to achieve safe buildings and make them safer for people to come back into, meaning your constituents. And the way we do that, per the CDC and ASHRAE, is by maintaining a constant temperature and humidity, and maintaining ventilation in these buildings, and doing some sort of air purification. The key to this is being able to gather that data and prove that it's doing what it's supposed to do, that we are in fact making these buildings safe to come back in based on those three items, and being able to serve the people that come to them.
So these are three key points, I think, of why it's important to have smart buildings as part of a smart city in general, but also we'll say a smart city either master plan or initiative. Number one, especially in rural communities, the municipality is typically the largest commercial property owner in that area. And so, you have a lot of square footage under roof to manage, to operate, and having that be potentially 25% of just managing that and managing deferred maintenance, 25% of your annual budget. That's a significant amount of budget that's applied to that. And ultimately then leading by example and demonstrating for your constituents that we have a plan and we're going to be able to execute that plan, and ultimately be better informed about how we're, number one, spending your tax dollars, but most importantly, serving you as our citizens.
Think about the other big group in any municipality that's kind of important, especially from the topics we talked about on the last slide with safety and wellness, is the public school system. Between the public school system and the municipality-owned real estate, probably comprises a very, very large portion of the commercial property. And leading by example, making those facilities safe, gathering the data, making them usable, and making those buildings work for constituents and occupants will attract additional industry, will attract people who want to live in that community, and will attract business into that municipality. We look at this as the anatomy of a smart building from the facility-centric type view to the people-centric. And we'll explain what that means. Is when we look at the facility-centric, it's the actual infrastructure in the building. So it's the energy management system, the equipment that we're managing, whether it be elevators, HVAC equipment, lighting, security, power, energy. There's a middle area where there is some people interaction with those systems, whether it be how we access the building from a key fob, or the security cameras in that building, or how we interact with HVAC if we're not comfortable in a particular space, or how it may change based on people moving to a conference room. And the next transition after that is what the building is actually doing for people. So how does it improve the productivity? How do we use it for commerce? And how does that building itself adapt to me as an individual, and how I use it and what I might have to use it for?
And the term ambient intelligence is synonymous with artificial intelligence, machine learning. So once you're really trying to move towards, okay, how do we improve the experience of our occupants, you're going to need that technology to be interacting with all of the various systems amongst the building.
Yeah, we do the facility-centric piece every day. and every commercial building has some sort of automation system where we pull that data is. The people-centric part is when that data is merged with other databases like financial, like human resource, and how that data is works in conjunction with each other.
So leveraging that data is the key. And yes, you're getting a lot of good data out of your buildings, but it's how you can interpret, understand, and use that data that's going to make the difference and essentially make your building smart. And so you can see the 4 key areas here that will allow you to make better decisions using that data going forward, right? So your tenant applications and services are essentially your employees and constituents who use your buildings. Security and accessibility systems, so that you want your buildings to be secure and be safe, but at the same time to be welcoming. And so there's a lot of newer technologies out there that are a little more passive, but yet can still achieve similar results and keeping your building secure. And again, building operations, we tend to focus on that one first because those are the relatively straightforward systems, but they then ultimately have to interact with all the other ones on this slide.
Yeah, and Joe, I'd say a good example of this, and probably the leader in the industry of doing all 4 levels of this, has kind of become the healthcare industry, where when a patient comes in, whether it be a medical office building or a surgery center, it's getting to the point now where they come in, they sign in as they arrive through their phone, through an app. Their patient files become accessible to the doctor that they're seeing. The room, if they're staying, gets set to the right temperature. The lights are turned on. Their medical files are made accessible to the proper doctors and nurses. And so that's an interaction. And oh, by the way, don't forget about the invoicing piece. It probably starts the financial invoicing piece as well that we all come to know and love from our visits to the doctor. But that being said, all those systems are interrelated and connected together, and it all happens seamlessly instead of being a human touch point of passing it off to the next individual.
So you're asking, how do I know if I even have started on the process of understanding if we have smart buildings, or where do we start and where do we assess on how we have smart buildings? So we wanted to share these, we'll say, thought-provoking questions for you to consider in your communities, that, how do we start on the pathway to making our buildings smarter? And for example, the first one regarding your building performance, there are a number of tools out there to do that and understand that. But then where do you take that data? For example, if you have an Energy Star score of 80, that's great, wonderful, you're doing a great job managing your energy spend in your building. But then how are you using that to leverage other opportunities within either doing capital projects or buying more equipment or better equipment for not only your employees but to serve the constituents that in the community that you work in, things like that. So essentially what we're after here is that how do you start to unpack this smart buildings concept and make a plan, an actionable plan, to take the right steps to move that forward?
Yeah, and I'd argue that a lot of the buildings that we have, public sector type buildings, are already on their path to being the so-called smart building. In other words, that data is available. We don't necessarily know how to grab it and what to do with it. And the great example is from a budgeting standpoint of energy and utility usage. We simply look at what was used last year and maybe increase it slightly based on utility increase without any actual data behind it to see, well, what did the building actually consume? Or knowing how it's consuming energy as we go month to month to month. It's usually a rear view mirror type aspect of saying, well, this is what I did last month. Well, by that time, it's too late to do anything about it. So gathering this data up front and being proactive with it enables us to make business decisions moving forward to take corrective action before it's too late. Here's what we see as the vision of a smart building. And it's a complicated slide, but to break it down into two major components, the building assets and sensors. So every one of those systems towards the bottom of this page are currently, for the most point, disparate systems. They all operate independent of one another, whether it be the HVAC system, and there might be a little hardwire interaction between HVAC and smoke and fire alarm for smoke evacuation systems and humidity sensors, temperature, that comes into the HVAC. But those are typically totally disparate from things like elevators, power, surveillance, card access, and we've even got charging stations on there as the electric vehicle becomes more prominent. They all become currently separate systems. We're seeing a rapid movement into bringing those all together to make decisions in the building, not only of how we maintain and operate that building, but how that building is used by the consumer. And a great example of that on a really small scale are some of the retail establishments. There's technology out there today that's able to track a person as they walk through a store, a retail store, and find out which kiosk are they spending time at. What do they see when they first walk into the store, and track their movement. The same token is how that interacts with HVAC. And does this conference room all of a sudden have 25 people in it? We need to adjust that temperature, other than when it's totally unoccupied.
We're going to touch on this a little bit later too, but it's really trying to shift from a reactive management, building management stance to a proactive. And while that's easy to say, it's difficult to do. But these systems and these tools can really start to move you in the right direction. And how that looks is that bottom bar, the blue bar, the building infrastructure bar. Again, those are those traditional systems that have their own controls. You interact with them through various different ways. A building computer for the HVAC system. You know, your elevators are getting smarter. You can actually just call them now from your phone. So there's interaction with these various systems to either the end user, or the employee, and the facilities team. But then how do you roll that up into something that's useful for you as a community to show, okay, here's really how we are becoming we have smart buildings and we are a smart city. The traditional building management systems you see in the green bar, you know, those are your typical HVAC control systems, and have user interfaces. You can interact with them, but it's still not intuitive. And so what we've been asked to do in a number of cases is add a simple dashboard on top of those to just monitor the key variables. We all have a limited amount of time right now. Everybody is managing through a lot of new things. And so, for example, we've had people ask us, I want to watch outdoor air temperature, my space temperatures, my space humidity, and how much outdoor air I'm bringing in to flush my building, especially during these times of COVID. And so just those 4 simple things, they can go on a dashboard, and that can start being your foundational building block towards your foundational building block moving towards becoming a smart building in a smart city.
Yeah, that building management level seems to be the centrist point of bringing a lot of the infrastructure systems together. And once those companies are moving into a direction of more of a software solution, and once we bring that up to that cloud-based integration piece, we see a lot of players that have not traditionally been in this industry collecting that data and having that communicate and transfer data from one software package to another.
And Jeff makes a great point there, because we'll touch on Microsoft a little more in a minute, but Microsoft is at the leading edge of this with their Azure platform. But there are others that are out there. And one to highlight is the Honeywell Forge system. Honeywell Forge, the intent of that system really is to make that presentation and visualization, and ultimately your understanding of the data and connected systems, that to make it easy and accessible for not only you as the municipality, but also for your constituents to understand, okay, what are we doing and how are we doing it? So for example, Honeywell Forge can take your traditional building systems of your fire alarm, your security system, your HVAC control system, and connect it with your operating system. So for example, they have an example out there of working with SAP. So those two now interact, and you can start making financial decisions and understand how those financial decisions ultimately impact your building operations, or vice versa. So again, building from the building infrastructure and having that being able to communicate up to the building management, to the building automation, and ultimately to a presentable, easily understood view of what your building is doing. That's the key to working towards a smart building.
So one of the companies that Joe and I are pretty familiar with is Symmetrics. And Symmetrics has been gathering building data for probably the last 20 years and developing algorithms to analyze that building data. And one of the outcomes of that and the analytics is really to enable a building operator to make financial decisions off of it. So if something isn't operating correctly in a building, what's that costing on an annual basis in energy? If it's not operating correctly and it's costing money from an energy standpoint, is it little or is it a lot? And really being able to make a financial decision is, do we want to repair it now? Do we want to repair it later? Is it something that we need to budget for and be able to make a capital decision on? Secondarily, is it a matter of safety or comfort? And how does it impact our constituents and occupants in that building? But it enables them to make a decision far beyond, well, it's broke, let's fix it.
We also want to highlight machine learning again as one of the key buzzwords that's out there regarding smart buildings. And machine learning, artificial intelligence is coming. But the key here that we wanted to highlight was that, yes, you can go through similar steps to what machine learning will accomplish for your building. And again, you're moving from descriptive to prescriptive, or essentially reactive to proactive. But what the machine learning capabilities do is, number one, increase the efficiency and how fast you can get to those answers, but also, capturing, okay, we made this decision, how did it work, and what was the outcome of that? So essentially, what the two can do similar things. However, machine learning can just makes you that much more efficient, and allows you to then potentially dive deeper and deeper into the data as far as you want to go, to make an informed decision and say, okay, my rooftop might fail in a couple weeks. Do I want to replace my rooftop unit now? Yes or no? Or do I want to replace my pump now? Yes or no? And you'll have additional details of the costing of that and the what the potential risk is if you wait another week. That can just help you make a better decision budget-wise and for your operations to ensure that you're minimizing downtime and any challenges that you could have from that.
Yeah, and machine learning, again, is one of those buzzwords that we hear often. It's really the systems learning from themselves as they make adjustments. And in the building maintenance area, it's, are we making the adjustment over and over and over? And is it costing us is it costing us money in the form of human interaction, or is it something that the system itself can adjust for without having a human to actually touch it and make the adjustments? So this is an example we thought was rather interesting because it involves a lot of buildings, and it involves one of those new players, Microsoft, into this area. We've known Microsoft obviously as, software operating system, but really what they are is in data management. And as buildings become smarter, as smart grids and communities have more data, we see Microsoft as being one of the players in the future of being able to gather that data. This is an example of what they did within their own campus. And they started out with how do we make decisions on that are cost effective and impact our tenants and our facilities themselves. And so, they looked at 13 buildings. They have an entire campus of 125 buildings, a staggering amount of HVAC equipment, and tremendous amount of data. I mean, we're talking 2 million data points with 500 transactions during the day. And how do they get their arms around that? Obviously, they can't have a person looking at all this data. So they had developed a number of fault detection and diagnostic type algorithms that analyze that data and identified the top alarm and energy management type scenarios that that would have a big impact on those facilities.
And we'll touch on a couple more. One of our partners will touch on a couple more examples going in the next couple slides. But I think the other key here is that this demonstrates that even Microsoft is taking this in manageable chunks and migrating towards essentially smart campus or smart city within their own organization. And so that again is you're using this initial, we'll say, test bed of the 13 buildings to better define, how you continue to move forward with this initiative.
And the results were really reduced the number of work orders on a month. To have 10,000 work orders a month, you can't have enough resources to be able to handle all that. But they ended up achieving 6 to 10% energy savings per year, which, when you think about 13 buildings and the amount of energy they're consuming, is a pretty staggering amount, with an 18-month payback overall. So the results were very good, and it was really leading the industry by example and showing what they can do by analyzing the data. So we wanted to give a view of the overall smart city. We talked a lot about buildings and how buildings interact in that smart city type concept, because it is a big part of it. But there's a lot of other areas as well, whether it's be education, economic development, energy and utility, public safety. How do we transfer data for retail consumers and promote it? We've got a guest with us, Ty Miller from Schneider Electric. Schneider Electric, if you're familiar with the company, owns Square D, so very big in the electrical field. They're also a leader in microgrids and utilities. And so I'd like to pass it off to Ty Miller at this point, and Ty is going to talk about the bigger picture of buildings and how they interact in the utility grid and how it fits into the overall larger picture of smart cities. Ty?
Okay. Well, thank you, Jeff. Appreciate that introduction and everything you and Joe shared about smart buildings and where things have been and where they're headed. I am Ty Miller. I'm with Schneider Electric. Been with them for almost 20 years now in their energy sustainability services division. Also a director in the Smart Cities division within Schneider. Schneider's had a Smart Cities offer and division since around 2012. Really started out in the electrical grid space globally, and has since over the years moved into even more dynamic smart city as the more and more technology comes to be. So appreciate being here and getting to share just a little bit about some of what Schneider has learned over the years and some potentials for your cities and municipalities. So once again, Jeff and Joe did a great job with the smart buildings concept. As you all know, each building is tied into the electrical grid, and unless it's an island building with its own local generation and has, which are becoming more and more common, more and more municipalities, especially their critical infrastructure like police stations or jails or wastewater plants, they might put a little microgrid in so that they can be more resilient. But even then, they're typically also connected to the grid and can use the grid's power as well. So once you start talking about all of the people out there that use electricity, right, and all the buildings, it becomes quite a dynamic system to control. So getting our grid, especially in the US, we're a little bit behind the global way that a lot of grids operate. Our grid is still really not very dynamic. And so one of the projects that I've worked on recently was a project, the downtown Chicago buildings, hooking them up with the right sensors and systems so that they could be almost instantaneous on replying to grid demands. So for instance, if a huge Google server needs to ramp up to do some algorithm, you could be a downtown building in Chicago, and the utility through the ISO could send a signal and say, hey, we need more power, and that building could perhaps ramp down, for instance, a chiller that it might not be needing at the exact moment. For that 5 minutes, 10 minutes, however long, the grid's calling for it, and then it can ramp back up. All automated processes, and then the building owners would get paid for that response as well from the utility or the ISO. So we're seeing a lot more and more buildings becoming smarter, not just to demand response, but frequency regulation and all things. As I discussed earlier on the microgrid, to be able to go back and forth from using the electricity that comes off the grid via inputs from the grid or outputs that they want to send the grid on their own because of the way they're trying to operate their city or their buildings. Another aspect of smart city, important one, is smart mobility. So just one example of this, I'm sure you've all probably sat at a stoplight waiting for traffic to come by. You're there, just stopped, and the road in front of you is empty with green lights. We have made progress over the years to get into more of a timed traffic system and or even sensors under the pavement. But where things are going in the very near future, and already there, we're already doing a project in Dallas, Texas, where there are sensors throughout the city that are constantly monitoring traffic patterns. And so between the sensors and cameras, the traffic lights will change based on the very direct needs of each individual intersection, and also be able to forecast what's coming in the next 1, 5, 10 minutes down the road. So those are some examples of some very real technologies that are currently in place and are going to continue to grow over the years. As electric vehicles become more and more prevalent, there are going to be more and more charging stations. Those charging stations and the cars and vehicles that are hooked up to them have batteries that can also store power, so that will be connected to the smart grid as well. Once we have a lot of batteries out there, it makes our grid even more dynamic. So as these are layers upon layers of each other. But so we talked about smart grid, smart mobility. Let's move on into the smart water space. So when it comes to smart water, there are a number of systems and technologies that we know exist now and can be put together to operate and give more knowledge to not just the end users of the water and wastewater plants, but the citizens as well that utilize the water and all the way up. So one big example of this currently in our current situation in 2020 with COVID is there are now sensors that can detect the virus in wastewater. So you can imagine a time where there will be a number of sensors that are detecting perhaps it's illicit drug use or like I said, with the virus, and be able to figure out specific areas and locations where there is an emergency that is taking place, and being able to pick up on that signal within the noise a lot quicker than we can today. So a number of nodes and signals that would work together to make the water distribution system safer as well as smarter. Just another example, right now we're doing we just finished up doing a project with a city in LaPorte, Indiana, where now they get real-time data if a customer, a homeowner has a leaky toilet. The system knows that, sends it to the programmer, and then an alert goes out to that homeowner that there is a leak in process. So it's all automated. It's all very dynamic and responsive, and so that's just some of the examples of where we're going and headed, and where we already are in the water space when it comes to being a smart city. And finally, I want to talk a little bit about just smart public services and ways that we can make city services smarter. And this really just comes down to an overlap of the technology, right? When we start talking about services, it's not just the technology, but it's how that technology is utilized. So depending on what the city wants to share, oftentimes cities are in silos, and communication is blocked from one department to the next. But that's really changing with a smart approach, so that the county officials would get a notification right away if there is for instance, an active shooter in a school somewhere that might be outside of the county limits. It's still coordinated up through a network that optimizes and sends signals to anyone that might need to know that right away. We see this pings on our cell phones, right? With if there's a missing child or any kind of an emergency. So the services aspect of smart cities is also very, very important. So we've talked about smart energy. We've talked about and microgrids. For instance, we've talked about smart mobility and traffic management and charging stations. We've talked about smart water and whether that's sensors that can communicate a storm event that is coming based on telemetry from weather stations, or whether that's just a network that is constantly monitoring where the water leaks are. All of those are part of the smart water solution that exists today. We talked about the smart public services and how that oversees everything. We're in the process of a program right now in Lincoln, Nebraska, where their streetlight management will be able to communicate within each other. If a streetlight goes out, someone will be notified so that can be repaired quickly. So those are the types of send service trucks out to fix it. So those are the types of services that overlay the entire idea of a smart city or region. And then, of course, the smart buildings and smart homes that was touched on earlier. Just a few examples here as we wrap up. I've talked about a few of these, including Dallas and Lincoln. But in Madrid, Spain, for instance, they currently have a critical center, an operations center that manages all of the traffic within the city via train, bus, cars, and is constantly changing patterns based on track patterns for the trains, or traffic patterns to help if an emergency vehicle needs to come through, they can shut off stoplights so that the emergency crews can get to where they need to go. These are all projects that have already happened, and so we are quickly moving from the shallow end into the deep end of the smart city space as we are now in almost to 2021. So just to wrap up here, we've talked kind of at a high level, and I think that was the intent of today. But I think no matter what size your city, county, region, if you have assets, whether those are any kind of citizen services, that there are likely new technologies and new approaches that can be taken to make those smarter and more robust for your citizens. So it really just starts off with a profile to determine what assets exist, and then we'll jump into the analysis to determine whether or not there is a opportunity for what comes next. And the good news with a lot of these, most of what I've discussed today is been paid for by efficient upgrades. So it's not adding any fees to most people. It's not adding taxes. It's using current approaches to save budget dollars or bring in new revenue that pay for this. So that's all part of the analysis as well. And just trying to determine, what kind of software as a service makes sense. What are the financials that back that, and what's the business case, right? Almost all of these have a business case associated with them. So it's a good stewardship of tax dollars, as well as the ability to provide more direct, smarter services to citizens. So yeah, it starts off with a profile and analysis, and then you go from there. And that pretty much wraps it up for me. Thank you for the time. I appreciate it. And with this, I think I will turn it back over to Jeff Stone to wrap us up. Thank you, everybody.
Thank you very much for your presentation, Ty. At this time, we're going to take a moment and give you a little preview of our upcoming webinar that will be happening after the first of the year. So keep your eyes open for an invitation to join us for that session on transportation, and we will get messages out in your email and on social media. After this message, then we'll all come back together with Jeff, Joseph, and Ty, and we'll have some time to answer questions about smart buildings and smart cities. So please enjoy this, and we'll talk with you more in just a minute.
Hi, my name is Abby Tanner, and I'm a member of Kapur's Smart Cities team. Our next webinar will discuss new insights into finding the correct pedestrian safety solution. Pedestrian fatalities and injuries are on the rise, even with traffic volumes decreasing during the pandemic. Our webinar will focus on solutions to increase pedestrian safety at intersections and mid-block crossings. These include traditional methods like RRFBs, LED enhanced signs, and beacons with enhanced pedestrian detection technology, as well as connected vehicle interfaces that can alert drivers within their vehicles. Thank you for attending our second webinar in the Kapur Smart Cities series. We hope to see you at our future event in February.
While everyone's getting their cameras and microphones back on, thanks again for presenting and being a part of our program today. We have had a couple questions that have come through, and so I wanted to just, I'll put those out to everybody here. But one of the first questions was, can a building of any size get value out of this type of analysis and the technologies? Is that, maybe we can start off with Jeff and Joseph and see what your experience has been.
Yeah, I think a similar scenario would be if you have a Wi-Fi thermostat in your residential home at this point. So commercially, they've developed products of the same concept and at a much lower price to be able to communicate with the larger so-called cloud network and gather that, not only control the equipment economically on a smaller scale, but be able to pull that data out.
I think just, Jeff, one thing to add to that is, the monitoring and analytics service can tend to run between 10 and 20 cents a square foot. So essentially that's how you can scale from a building of a small size up to a large size, because it's all depending on how many points are being monitored. So yes, to answer the question, yes, it is scalable down to a building of any size.
And then just one more thing on some of those products, the analytics are already embedded in the product. So I'll give you an example. I have a Wi-Fi thermostat at home, and every month I get a report from Honeywell whether I want it or not. And it tells me how much energy I've used this month and how it compares to the prior year.
Great. Ty, do you have thoughts to add on that?
Yeah, no, I think that they summarized that pretty well. I believe no matter the size of the building, whether it's a residential house or a huge skyscraper, I think of just about any building these days can benefit from smarter technology.
I had another question, Ty, that came through online for you about, are there any technologies being incorporated possibly in communities in Wisconsin that you've worked on, trends that you're seeing happening based on the size of a city? What are the biggest roadblocks you see to incorporating these technologies into smart buildings and smart cities?
Sure. Yeah. The biggest trend we're seeing lately is this concept of a microgrid. So having a demand response, you can generate your own power there locally, and it's resilient. And we're seeing this a lot at wastewater treatment plants because that's a system that uses a lot of electricity anyway, and it makes for a really good application for microgrids. So microgrids are the biggest trend we're seeing in the space right now. There's a lot of incentives right now for solar. So a microgrid typically has a few assets, right? Sometimes a CHP or a generator that can generate solar or some renewable power as well, and battery or storage all combined that allow for buildings and plants and processes to work outside of the normal grid operation. And so if the grid were to shut down, they can island and they can work police stations, and are another good example of a building that would definitely want to have no downtime. So that's the biggest trend. I think the question about roadblocks, I think cities typically have a hard time either chewing the whole elephant at once or taking really bitty pieces. And with a lot of this technology, it does interact. So it does kind of need to be a larger project for it to all work really well. And I think that usually there's multiple departments that are involved in that type of a implementation. And so it's just a matter of coordination as a roadblock with all the departments involved to be able to coordinate a project as well as fund it.
That's one of the things I think is interesting with your background is, there's the technology of this, and then there's kind of the public policy and getting people to understand it and coordinate. So I think it's a valuable perspective. What about Jeff and Joseph? Are you seeing some of these elements being incorporated into Wisconsin communities?
It's Jeff, it's just starting, and Ty, you made a great point there regarding some of the technologies. I think one of the pieces though that communities are struggling with is that where do we start? And I frankly think it relates to your capital planning and having a master plan. I think starting with a master plan, and that's where we've seen Ty and his team interact with municipalities in and outside the state, developing that master plan so that you can then start to roll out pieces of it. Because if you try and take on the entire elephant at one time, it's too much, frankly. And so, we think that's a key step that's, we'll say, relatable to other business and other efforts that are already going on within the municipality.
I think the other piece that plays into the whole microgrid concept is whether or not the utility is deregulated in that area or not. So, for instance, in other parts of the country, electricity is deregulated. That utility here in Wisconsin, it is not. However, the purchase of natural gas is. And so we've got a lot of our larger commercial customers who are buying natural gas, not from We Energies, but through a broker or a third-party distributor like a Constellation Energy. And there's several of them out there. So as that becomes more predominant, I think you're going to see in this particular area the concept of the microgrid becoming more popular.
So the other topic that I'm kind of interested in are, we have a lot of this data that's there. Do you think that most communities are actually making use of the data they have, or even building owners? How many of them do you think really make use of that data? Kind of like that report you get, Jeff, that whether you want it or not.
Yeah, I'd say very few commercial building owners and or operators use their building automation system to its fullest. And that's one of the problems with it. One of the things that we do from a service standpoint is going on a quarterly basis and recommission those systems because they kind of tend to become manual systems. They're called building automation systems because they should be automatic if they're programmed correctly. And in a lot of cases, they're not, because of whether it's because of changing internal or external environmental conditions. And then over time, they kind of get out of calibration. But from using that data and pulling it out and being able to make decisions with it, very few people are using it to the fullest.
I would reiterate that. I think a lot of cities are just they're understaffed. I mean, budgets are always tight, and so just because the data resides there, it doesn't mean anyone's full-time job is to look at it. So to back to the trends, like Jeff was talking about, another big trend right now with the pandemic is making sure our buildings are safe, right? And so we can do that with smart technology. Joe and Jeff know how to go in and monitor those buildings and make sure that they're getting the right amount of outside air and shutting them down when no one's in them, those types of things. But it often does take, some cities are big enough and they have the staff to monitor those types of things on their own. But I've found typically, especially in the public space, the smart technology and someone kind of automatically watching that is a big help.
Yeah, Ty brings up a really good point in the whole pandemic era is, there's really three things that we look for in making the indoor environment safe, and that's Is the temperature and humidity being held within the parameters that the CDC and ASHRAE have outlined? Is there enough ventilation in that facility? And is there some sort of air purification? And, I believe at some point in time, those are going to be three things that people are going to want to have a record of has this building maintained those proper parameters, and is it safe for people to return to? And we're starting to see that trend happen with commercial building owners already.
All right. You talked a lot about kind of that initial assessment process. Is that something that takes a long time, or, how much effort does that require on the part of a community to kind of begin this?
Yeah, from my perspective, typically it's not too cumbersome. I mean, that first step is really a pretty high level just to look at the opportunities. So it really just takes someone that wants to invest some of their time and allow our groups to come, do some site walks and ask a few questions and put together kind of an initial, like we talked about earlier, business case that kind of describes, or a master plan. This would be the very beginning of that. We wouldn't delve too into it until we got feedback and understood, the specific needs and the opportunities. But no, that first step is it's a pretty painless one.
Yeah, and from our perspective, the building itself, it's really, what's the inventory that's in there of equipment? So from an HVAC standpoint, it's what's the inventory of equipment that's in the building, and what building automation system do they currently have, and what's the age of it? And depending upon that, it may not be we have to replace everything, but there's a migration path to bringing it up to a level of technology that we can then gather that data.
And based on that, everything you're saying, whether it can be applied in a public buildings or privately owned buildings, all of these things work on both of those sides. So it has,
Yeah.
That process is going to have value whether you're a private developer or a municipality with multiple buildings or something like that.
Mm-hmm.
Yeah. All right. Well, we've gone a little bit past our time, but I want to thank all of you for your presentations and their contributions here. I think we've kind of laid out a path that I think municipalities could begin to move forward, and it sounds like there's a lot of opportunity for these improvements to be self-funding from existing dollars. So some of those hurdles that a lot of times elected officials might face of, how do I come up with new dollars? It really can be internally financed and make some improvements and really offer better services for both the constituents and also for the employees and folks who work in these buildings.
Well said.
All right.
Thank you for the opportunity.
All right. Thanks for being with us. Appreciate it.
Thank you.
All right.
Thank you.